Okay, my outstanding friends, this is going to be fun. I hope it will be for me. I can guarantee you that. Now, they have just discovered the ghost particles in LHC for the very first time, 29th of October, 2021. I've been seeing these same particles, I believe, for quite some time. Now, a major milestone in particle physics just been made at the Large Hadron Collider. The first time candidate neutrinos have been detected. Not just at the LHC, but in any particle collider. Now, they saw 6 of them, 6 neutrino interactions detected using the neutrino all these business. Not only demonstrate the feasibility of the technology, they open up a new avenue for studying these mysterious particles, particularly at high energies. Let's see if we can see these particular particles at particularly high energies. All right, now let's just get this out of the way because it always comes up. We can see these particles with cell phones. Long ago, 2014, we were watching these things with cell phones. They turned the smartphones into pocket cosmic ray detectors. That's because that's high energy, extreme luminosity, radiance, not just anything. You can detect cosmic rays in much the same way as high-end multi-million-dollar observatories. All right, before I show you the neutrinos, he's saying that prior to this project, no sign of neutrinos ever been seen at any particle collider, says Jonathan Feng from University of Irvine. Now, then down here somewhere it says neutrinos are actually everywhere. Well, they are, although they interact rarely, and that's because they're literally glued as, like super glued together to the other part of the neutrino. Well, let me show you the particles and then we'll talk. Now, they claim nobody's ever seen neutrinos, and I claim we've seen them, and tons of them, and here they are right here. Now, the black ball is the muon neutrino, and that's this one right here. When it comes in attached to the white ball, it concusses. The white ball turns into showers. The black ball turns into nothing. It just keeps going the same way it was. Let me show you these particles. But just so you understand, these are the neutrinos. They just talked about them. And that's the electron neutrino shower. And this is the black ball, which was attached to it. And it just doesn't do anything. It just stays the same as it is. And that is exactly what happened here. These were attached together. They were in a formation like this. I'll show you in a second. And when they hit, the black separated from the white. And it because there's a tiny, tiny, tiny little venturi slit here, which accelerates the light and forces it to crush. That's the only way you can get this interaction to happen, other than having to accidentally bump into each other, which is what they've been seeing. And they saw 6 of them and were excited. I could see more than 6 there. Okay, I'm just going to sort of roam around through some of these shots. Again, I did this research long ago with Rod Warren, so this goes back 6 years ago, and I did try to alert everybody on the planet to this, and it was not well received. That is light, which is, to me, is the smallest particles. They don't really even understand what light is. So I'm saying that is light from a pulsed red laser. We're using smartphones to pick this up, which is CMOS technology, works exactly the same as CERN, and we are seeing these highly accelerated, highly energetic particles. And that's the only way you can see them is when they're highly energetic. Out here where there's no concussions or anything, there's just darkness, there's nothing there. But once you start to get these extreme concussions, the more brilliant the glow, the more energetic the particle. It's as simple as that. This wave is being accelerated forward. It's quite obvious. It's and smash. Here, the black and white particles separate. Now, like I said, I'm just going to roam through this. Normally, I wouldn't make you sit through this, but what the hell, I sit through it. Here's where they come in. These are the particles coming in. Again, you see up here, there's no concussion here because the slit is right here. It's right direct in line with the slit. They're backing up, backing up, backing up. Energy field to field to field to field to field. Now, back here, they're not just, there's nothing. So, originally you see them in that configuration there, which normally, again, you don't see anything up here. This stuff it's everywhere. It's here, but you don't see it until it starts to get really close to the wall, basically. Now, what happened here? They're starting to show their different potentials. And here they're just really starting to back up as smacking into each other, which apparently makes them show up as they are in this exact configuration. And they all do that. The green ones, the red ones, and the blue ones, I believe, too. The blue ones are harder to see, but I believe they're the same. And as they get, just before they concuss, they spike up, and then they do this, boom. And then they explode, and the black separates from the white. As I showed you, let's go back and see that again. And that is precisely what they are calling the muon neutrino. The black one just goes on its way, and the white one turns into the showers. There they are. I mean, I think I've seen that, shown that pretty conclusively. So we've seen that they've come apart here. The black has come apart from the white. There's nothing but white here. There's zero except whiteness here. And they come back together, back here. The blacks come jumping right back in. They want to be attached. Those are the gravity. Those are the muons, the bosons, the carriers, dark matter. It's all the same thing. It has no absorption, no emission, no reflection, and it stays the same size here as it is over here. And if the slit is the right size, it can't get through. The white can concuss, and I can show you that for a fact too. Let's go see what Fabian had to do. Rod's work, and I had a bunch of other people look into this and highlight this and that, and Fabian Boulet over there in France. Hey Fabian, how you doing, buddy? He highlighted a bunch of Rod's pictures, and I mean to me it was phenomenal. So here we are with that photon. And I'm saying it's a photon. It's a back-to-back electrons. Electron, here, let's just be sure you fully understand what I'm saying about the atomic world, or subatomic world. Because this is where everything's wrong until they can get down to the dipole nature of the nucleus. That's the problem. So there's electron flooding, which means everything is made of electrons. And that's what an electron is. It has that dark side, and it has the white side. The dark and the white, the dark and the white. Two of them together is like two bar magnets, back to back, glued together. Now, going forward, the leading one puffs up and glows because these can concuss. You see how that's smaller? These are big. They never change. They never change. They're the same size coming in as going out, hanging around the edges everywhere. These puff up and explode and get big and get small. And they can squeeze through the venturi. So that's what an electron is. Two of them back to back, you just saw as a photon. The muon is when the black separates from all of the rest. And in the meantime, back to back an electron, they would call it an electron neutrino and a muon neutrino. Photons are nothing more than those back to back. Muon is the black part, the electron neutrino is the white part. Atoms are when you add all of these together, because there is nothing but electrons. There's no protons. A proton is 1837, or it could be 1839. I don't know. It's right in that area of electrons. And then you add one more, and it makes a neutron. So a proton is the odd number. The neutron is the even number. So 1836 or 37, let's say, and 1838, that type of thing. And that makes matter. And all of them, like another one attached to here and sharing the white parts, would make a molecule. That's just me. Now, electron flood says there is nothing but dipoles. Nothing but dipoles. So heat is nothing but electrons. Heat, that's heat, electricity, lightning, static. It's the actually totally independent electron. Now, if the black ball went away from the white portion, that's what's called a sterile neutrino, which is all by itself, sterile. And we can do that too. And I showed you, they're all got sterile neutrinos, and you know, they're all sterilized. Now, we got photons, which flood, and that's the light. Now, if you create the venturi correctly, that's when you break the light apart, and you end up with the dipoles, and then you end up with the muons and the electron neutrinos separated. Now look at something really careful here. I think these also came from Fabian. You see these six-pack box in the center? See the six-pack over here? That's what happens to them. It forces them into, as they spin, the particles are spinning. These are not just a flappy wave. It's a spinning particle, and I show that in extreme detail again. Now, they are coming out of the Venturi at us. If we were standing here looking in, that's the wave coming through and sending out all of these Higgs fields. And they, at this point, are separated from the other part of the particle. So they used to call that the God particle. Now I think they got more gods and more particles. But anyway, this is the Venturi here, and we're looking into it, just like we would be looking into this Venturi. So all of a sudden, between here and here, there's nothing. See, it's totally empty. It's void. Well, it's not void. It's just total energy. It's plasma, basically, at that point. That's nothing but the white part of the energy. And then the white part of the energy collides with the world, and they glow back together. The black jumps back into the white. And that's when, this is the leading tip of the thing coming at us, right here. And you can see that this one here got squished, and it elongated the wave, or the I guess you'd call it a wave, I don't know what you call it, the disk. It's crushed it and forced it to elongate, just like you'd pull on a spring, just like this. It's spinning forward like this, and all of a sudden it crushes in on the sides, and it goes, you see it? Only makes it speed up, and that's what turns it blue, because blue is a more energetic color than red. And the only way you can get to the blue is to increase the energy of the particles. And it just happened on the fly. We can look into these in real close detail, but there it is showing up here. We have different colors, all produced from the red initial color. So I've always said the Rutherford's atom was not correct, and it isn't, because you can still maintain that same particle and that same light wave, if they want to call it that, and have it different colors, even though it's the same one. You can just like we're doing with the Venturi. It's like here. All right, so anyway, this is something that we really want to take a look at. Isn't this cool? It's spinning like a crazy as it comes at us. That's what light does, it spins. I'll show you. No, you can see it's quite obvious it's spinning. There is a particle, absolutely, but the particle spins and it goes forward. And some goes through the slit this way, some goes through the slit that way. So most of them go through the center because they're going to be going from both directions. This is all a big circular batch of different particles. And that's why they separate coming out the other side. They do not want to be next to each other. The energetic ones that glow don't want to be next to each other. The ones that are dark, you can't see them, so, and they don't care about being next to anybody. They want to be next to the black or the white, the glowy ones. That's the only mission they have in life that I can determine, is to bring the glowy ones back together. So as these go through, the white one says, you get away, you get away. And the other one says, you stay away and I'll stay away, and everybody just stay on your own path, and we'll all get out of here on our own pathways. That's what creates the interference patterns, not flappy waves going. This is only a single slit, so it has nothing to do with flapping waves coming this way and going that way. That is what light looks like as it spins. These things are not understood. That's the key. Everybody thinks, oh, we know how this happens, we know how that. No, they don't. They really have no idea whatsoever. It's always been assume this and assume that, and then whenever you ask a question, they say, well, just look it up. Well, you look up, what are you going to look up? I'm showing you something that I want you to look up, don't tell me to go look something up. Okay, so they claim that for the first time ever, I say no, we've seen them a long time ago. These are the particles. Now listen, the collaboration is also eyeing even more elusive prey. They hope to pin on the detection of dark photons, which are at the moment hypothetical, which could help reveal the nature of dark matter. The dark photon is just the dark part of a photon, which is a sterile neutrino, or sterile muon neutrino, the mysterious, directly undetectable mass that makes up most of the universe's matter. Here it is right now. So once again, I say these came in just like this, as you saw, crashed, split into pieces, and are the muon neutrino, the black balls, and they never change. They stay the same, and that's exactly what CERN and the rest of them say. And the electron neutrino, which is the explosive electric charge part, that just explodes like an atomic bomb, and it literally is an atomic bomb. That is a subatomic particle on steroids. And here is that subatomic particle. It is a photon. Now, these will never come apart, basically. They'll bounce off of things, and you see them as light. That's fine. That's their job. No problem with that. But to force their way through with the pulse of that red laser and that tiny slit and that venturi, we were able to force and squeeze the little white ones through the slot, and the black ones couldn't get through. They came back out, and that was what caused this effect. They couldn't get through. The black ones can't get through. The venturi's right here. And the white one just sneaks through and squeezes through and like a hose. And these can't get through. They just come out of the way. And I believe that's what we have to do, is exactly tune that venturi. But I need somebody to do it. I can't do it anymore. And Rod can't do it. He's, we got lives to live. This was 6 years ago. I posted this everywhere. I sent it to everybody. And I still send it just literally weeks ago, trying to get through the Fermi lab. They won't talk to me because they say I'm not peer-reviewed. I said, what does that have to do with anything? I could accelerate light. I could show that light is a particle. I could create fission and divide that particle. I can create fusion. I think I can create free energy. But I'm not peer-reviewed. That doesn't seem right to me. No, I guess I'll wrap it up with this, because I'm just not getting anywhere with this. That is light, and I've known this for 50 years, that there was no such thing as a big positive core of positiveness and a couple little floating around tiny things that were called electrons. It didn't work. It had to be dipoles. There was no other way. And now I have proven it, and there they are right there. Now, that's light, and that's the pulse red laser. Bip, 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 bip. Well, there's particles in each one of these pulse waves. And in front of those particles, because they have that white, pushy, glowy part, everybody else has one too. And they'll say, no, 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 you can't come through. Hell, like hell, I'm coming. Boom. And they start to glow, and they push and shove and push and shove. And this thing here now has to get through that venturi. That wave would have just kept going like that, only it's approaching that venturi, which is a restriction designed so fine that it just accelerates. And they understand venturis. They just didn't understand that light is literally almost a fluid. It's basically a fluid as far as I'm concerned. It consists of all those little tiny particles, which are these little tiny particles. And they flow. You can make them turn corners. You can make them do anything. They're little particles. And they're coming through here, accelerating like a rocket ship and exploding and shuffling off the black particle. The black particle is gone. And it comes back here later. Fission, fusion. All right, these are what they call the Higgs fields. And they are coming out this way. We're looking into the venturi, and we're seeing the Higgs start to reconcuss right out here. That's where the Higgs are showing back up, right out there. So we've got this distance to here that we have to put some kind of collection device in here and harvest them before they go back into the environment. Now, you saw that. What is this? Are you seeing that? Are you seeing that? That appeared to be a reverse spinning particle when it came through the accelerator. And it's the only one I've ever seen like it, so it's not common. All right, this is a Majorna polarized twisted photon. And I'm going to tell you right now, they don't know how to look at light. They have never seen light before correctly. This is the spinning little light particles. Here's the Majorna looking things. All right. And Rod Warren he's got a magic touch with this stuff. He really understands how to capture things that nobody's ever captured before. I mean, look at this. These are green electrons, or photons. And this one looks like it's just getting ready to flip. I don't know. But it's stunning stuff. Look at this. Here it is. right up close and personal. Same thing, they call this the 2p2h. 2p's, particles, 2h's, holes. They never realized before it's a photon. That's all it is. And they know about this 8 years ago. I've been looking at this for a very, very, very long time. This is not anything new to me. And this is the spinning particle. It's a green spinning pulsed laser. And these are the particles. They spin, and then they have polarities, and that's why you see them as little bright spots. This is through, I believe this is through glass, a blue laser through glass, making a, you can see it, you see the little wave coming through there? It's concussing inside red electrons. You saw that, how they come in and then they form like that, and then they explode and divide. This is the blue one spinning. Now, this is, I believe it's coming in here really high powered, you know, and it looks to me like they're very close together. And it's a lot of glow there. It's drifting to the left. That means it's spinning to the right. Starting to expand in between each one of the little spots. And we're starting to see a separation. Here there is nothing. Up here you can see some little bit of a differentiation between the two little white spots. And I believe that each one of those is the photon. That's the spinning particle of light. That's what happens. It's just a single slit. There's no double slit there. This is that little bugger. Look at that. Now, this white particle came through here. These are the standard Higgs we got coming out of our ears. This, though, is nothing. Nothing I've ever seen before. This is the only one I've ever seen of it. And it appears to be forming a light disk from a backwards light disk. All I can say is it's supposed to spin to the right hand. They call it the right hand rule. If it spins to the right hand, it throws the fields out, is what it looks like to me. If it spins backwards, it pulls the fields in. And I'll show you the particle somewhere up here. Here it is right there. You see that white one? Now, I don't know exactly, to be perfectly honest with you, if that's what's going on there, but I can see there's some kind of a shadow, glowy looking thing there. Now, again, I don't know, that could be one of these from a different one. But what is that white particle doing there? It's coming out of here like these little spits of whiteness. That is raw electrons. And then when they explode into the environment that's around them, which is basically air, nothing more than air, it appears that these little white spritzers, bang, and they create these fields. And then the fields splay out, and then it just sort of plays out as it goes out. But that one there, I believe, is a reverse spinner, and it hit one of these and trumpeted off in that little tiny trumpet. Or this one here. Certainly interesting. And again, as far as I'm concerned, this Higgs field is the smallest part of light there is, except the other part, which is the dark matter part. And you can take it from there. And here they are on the move, Higgs on the move. You see them? See that one got squished. You see the particles trailing off of there? It's really, it's amazing how lost you can get in looking at this. There's a lot to look at here. Look at the little dot right in the center. I don't know exactly what is happening there, but I can tell you what. They keep throwing off these little ripple fields. That's another one. This is the cell phone he uses. I got one here, the exact same one. And that's just a particle accelerating out of the wave, exploding. So it might be time to look at this. If we could get free energy, that wouldn't be too bad. But with neutrinos, we got them, the white ones. Muon neutrinos, we got them, the black ones. Electrons are the white ones. The black ones are the muon ones. Fission, fusion. I don't know. I would think that somebody would be interested in contacting me. I showed here again. Here it is. There it is, Roger with no D at mudfossils.com. All right, that just happens to be where I did some other research. And you can easily get a hold of me there regarding this, and I would like to have somebody that can get this assessed one way or the other. Say the guy's crazy, or, well, maybe we got something going on here. Because until they realize, if I am right, and it is a dipole nucleus, which it is, it has to be. It has to be. And that accounts for everything. It accounts for 100% of everything, the excess dark energy and all that stuff. Because it loads into the center. It loads into the center. You see this? It forces the dark matter into the center, and everything there is crusted with white particles on the outside. But all the white particles that are outside, way out here, want to get inside past these white ones to that dark. That's why you get lightning and you get static, and they call it ground, because they want all the electrons out here want to get into that ground. That's what ground is. It's a place for electrons to discharge to. That means it's an extremely heavy dark matter object. Any mass of material is going to have excessive dark matter. Dark matter is just bigger than the white matter of the particle it's attached to it. I mean, it's almost as simple as that. It's hard to believe it could be that simple, but it's like the black ones are heavy and the white ones are fluffy. The white ones can squirt through, the black ones can't. That's why there's so much extra energy in the black ones. As far as I can determine, that's about it.